The easiest way to measure the volume of a container like this is, since it's water impermeable, simply fill it with a known volume of water. And you can do that using just a household measuring cup. We're going to fill it to 500 milliliters. Fill that container and look at the difference in what's left in the cup. And you can also use a digital scale if you happen to have one in your kitchen. A lot of people do these days. This is a top loading balance, but you don't really need this level of accuracy probably. So we're going to go ahead and fill that, and we'll look at the weight change. We'll tear out the balance first, and then which means simply zero it, and look at the change in volume in the measuring cup. It's important to note that the density of water is 1 gram per milliliter or 1 gram per cubic centimeter, depending on what units you want to use. But so 1 gram on that scale is going to be the equivalent of 1 milliliter. Now, we started out with 500 milliliters in our household measuring cup, which most people have. I'm going to put this flat down here where I can see it better and take a look at it. Okay, that's reading about, let's see, 75, 80. I'd say about 80 milliliters. So we started out with 500, subtract 80, we get 420. A little bit different than the gravimetric measurement with the scale, which is probably more accurate and most likely. So, but we're not all that far off. Depends on how much accuracy you need. 420 volumetrically of that household measuring cup, just over 427 milliliters with the digital scale. So that's how you can measure internal volume. It's actually pretty straightforward. Most people probably already realize how to do this. But how would you measure the outside volume of a complex shape like that? A little trickier, but we can do that also. Now, what if we wanted to measure the outside volume of this bulb? It will help if you've got a measuring cup that can hold the volume or the total object here. If we'll put that light bulb in there, and that's going to float if we fill it with water. But what we're going to do is not worry about the balance at the moment. We're going to fill this up, see if we can fill it up dead even with 500 milliliters of water. Okay, we've got 500 milliliters of water in there. It's right on 500 milliliters, and that's pretty much even with the top of this bulb here. So what I'm going to do now is I'm going to let go of that. Okay, let's take the bulb out and read it. We're reading 350 milliliters of water on the measuring cup. We'll write that down. Okay, since the water level now is reading 350 after we took the light bulb out, we started at 500. That's 150 milliliters difference, which should be the volume displacement of this bulb. Okay, we found easy ways to measure the internal and external volume of a waterproof or water impermeable object. Doesn't matter what the shape is, the same thing would apply. But what about something really unusual, like this Patrick Star Beanie Baby? He's porous, it's like a sponge, he'll soak up water. You can't use water. So how would we do that? Well, there is a way, but we're going to do that outside because it's a little bit dirtier process than just using water. Even though old Patrick here lives underwater in cartoon world, that doesn't work too well for measuring his volume. And you might say, why in the world would anybody in their right mind want to measure the volume of this? Well, most people wouldn't. But what if you were a sculptor in polymer clay, and you want to make something basically the same shape and size? You want to know how much the polymer clay to purchase. It'd be good to know the volume of this thing. So because stuff's not cheap, and so measuring volume of it could be useful to some people. Of course, this is just indicative of how crazy you can get with some of this stuff, but just want to show you how you can do it. Okay, how we're going to do it is we got some real free-flowing sand here. This is just play sand that I got from one of the building supplies. It could be sugar, it could be salt. It's got to be free-flowing though for it to work right. So what we're going to do is we're going to put this down in there, and what we're going to do is fill this up to the brim with sand and tap it and make sure that it's in all the nooks and crannies, and then we'll remove him and then replace that sand and see how much it took to replace it. So here we go. Okay, we've got this pail here completely filled to the brim with that Patrick Beanie Baby in there. So what we're going to do is remove it, and then we'll refill the sand and see how much volume that took. Okay, I've filled this measuring cup here with 1 liter, it's 1,000 milliliters of sand, and you can easily see why it's important to have free-flowing dry sand or some other granular material. Can't afford to have it clumping together. So what I'm going to try to do is get Patrick out of there without spilling any of this, if I can. Okay, let's try to get some of this off of him. Of course, got a little bit of loss here, but be pretty close. He's kind of plump, so he's probably going to take a lot of sand. Now, what we're going to do is just try to fill this back up, dead even with the top. Okay, we've gotten Patrick out of there. Got this filled back up even with the top. It's about 650 milliliters of sand in there. So 650 from the 1,000 is 350 milliliters. So old Patrick here needs to go on a diet. So hope you enjoyed this. Hope it's useful to you. And if you liked it, please like the video and subscribe. We would appreciate it. And check out our other links. Thank you very much.